Nama Toko Haryanto. Sini sebagai jabatannya jadi Danton, komandan peleton Danton.
Ya Pak.
Untuk dari laporan sampai memberangkat dari di sini 5 menit. Ya kalau misalnya untuk pemberangkatan, misalnya tergantung jauh dekatnya, ada yang 5 menit, ada yang 10 menit. Dan tergantung juga situasi lalu lintas. Kalau misalnya pas jam-jam kerja atau jam pulang kerja, mungkin agak padat, mungkin ya agak terlambat lah. Tapi respon time kita diusahakan di bawah 15 menit. Ya sana seperti itu. Istilah satu kondisi jalan. Terus kadang-kadang tempat itu tuh terhalang, ada gapura. Terus misalnya akses jalannya juga kecil. Terus kadang-kadang misalnya ada yang parkirnya, misalnya udah tahu di jalannya seperti itu, ada parkir kendaraan yang lain, jadi seperti itu kadang-kadang ya. Di antaranya seperti itu. Ya salah satunya masyarakat dihimbau agar misalnya memahami juga mana yang harus diprioritaskan untuk kendaraan pemadam gitu. Karena kita itu emergensi lah gitu.
In disaster management, every second matters. In Indonesia, the national standard requires that the fire department response time, from receiving a report to arriving at the incident location, should not exceed 15 minutes. Response time is a critical factor, as delay in emergency response can lead to greater economic losses, environmental damage, and risk to public safety. However, achieving an optimal response time depends not only on the readiness of firefighters but also on special factors such as travel distance and the distribution of incident location. Therefore, analyzing fire department travel time is essential to determine whether an area has adequate access to emergency service. This study focuses on Tanjung Pinang City by utilizing fire incident records and response time data to identify spatial accessibility patterns toward critical location.
The dataset we use come from the Fire Rescue Department of Tanjung Pinang City, covering all 20 fire incidents recorded in February 2023. It contained 8 key variables, including incident location, response time, fire cause, and estimated distance from the nearest fire station. Since the dataset had no missing values, our pre-processing focused on data transformation. As you can see here in the code, we extract response time into numeric minutes, categorize fire causes into 4 groups, identify each incident district, and map every incident to its nearest fire station, along with the estimated travel distance,
resulting in this transformed dataset.
Our analytical approach is exploratory data analysis, or EDA. We choose EDA because our core question is spatial. Does geographic distance affect how fast firefighter reach a crisis point? We produce 2 key visualizations covering response time per station and SLA compliance, which my teammate will now walk you through in detail.
Let's explore what the data reveals. This chart compares the average response time and average distance to incident location from each fire station. Pos Bintan Center stands out immediately. It covers the farthest average distance, and as a direct consequence, its average response time reached 10.9 minutes, exceeding our 10-minute SLR target. Pos Senggarang follows a similar pattern at 11 minutes average. In contrast, Pos Sukaberenang, which covers shorter distance, consistently achieved the fastest response at 8.1 minutes. The pattern is clear. The farther the station from the incident, the slower the response. Now looking at SLA complaints across 20 incidents, 75% were responded to on time within the 10-minute target. However, when we break this down by station, the delayed response are not evenly distributed. They are concentrated at Pos Bintan Center and Pos Senggarang, essentially the 2 stations covering the longest distance. Pos Sukaberenang, on the other hand, saw a delayed response. This spatial pattern is consistent and statistically meaningful. It tells us that the problem is not operational capability, it is geographic positioning.
In this modeling stage, we applied linear regression to analyze the relationship between the distance from the fire station and the emergency response time. The dataset consists of estimated travel distance in kilometers and response times in minutes collected from the fire incident in Tanjung Pinang. First, we calculated the correlation between these 2 variables to determine whether distance affects response time. Then, we trained a linear regression model using distance as the independent variable and response time as the independent variable. The scatter plot and the regression line show a positive trend, indicating that response time generally increases as the distance becomes greater. We also evaluated the model using the R-squared value to measure how well distance explains variation in response time. Based on the result, distance is an important factor affecting emergency response performance. Therefore, areas located further from existing fire stations may require additional emergency facilities or improved resource allocation to reduce response time.
Our analysis provides several important recommendations for decision makers. First, areas with consistently longer response time should receive higher priority for emergency planning and monitoring. Second, the fire department could improve service coverage by adding temporary response units or optimizing vehicles routes toward critical locations. Third, preventive education programs should focus on reducing open waste burning and improving electrical safety because these are the main cases of fire incident in our dataset. By using this spatial data analysis, stakeholders can allocate resources more efficiently and potentially reduce emergency response times in the future. Responsible data science also requires ethical consideration. This study uses public incident data and does not reveal sensitive personal information, helping to protect individual privacy. However, our analysis has several limitations. The dataset only covers 1 month, and some location coordinates are estimated. In addition, traffic condition and weather factors are not included. For future development, this research could integrate geographic information system, real-time traffic, and machine learning models to predict future fire risk areas. In conclusion, spatial data science can provide evidence-based insight to support faster emergency response and help build smarter and safer cities. Thank you.
In conclusion, response time is influenced by location and road condition.
Spatial analysis help identify patterns and critical areas. We hope this study can support better emergency response planning. That's it all from our group. Thank you!